example 8. A ship sails 6 kilometers in the direction 40 degrees north of east and then 10 kilometers in the northwest direction. How far and in what direction is it from the starting point? So the first thing you want to do is to try to represent this question in the XY plane. So let's see. For this question, we have the XY plane here. As you can see, we have our Y-axis, which is the vertical axis, and the X-axis, which is the horizontal axis. If a ship is starting from the initial point, the point of origin, if it's starting out, so we represent the starting point as this point. So a ship sails 6 kilometers in 40 degrees north of east. In this particular case, you find out that the ship moves 40 degrees north of east. I told you earlier in the previous videos that the north is usually somewhere up here. It's vertically upward. Your south is vertically downward. Your east is horizontally to the right and your west is horizontally to the left. If the ship sails 6 kilometers in the direction 40 degrees north of east, it simply means the ship traveled 40 degrees from the positive horizontal axis north of east. If it starts from here, you raise it up by 40 degrees and then that is how you determine direction of the movement of the ship. So we have 40 degrees here. In some examples, they will not give you 40 degrees. They will just tell you a ship sails 60 kilometers in the northeast direction. In that case, this is going to be 45 degrees. If this angle is not given here, this is going to be 45 degrees. But in this case, it is given as 40 degrees, so you have 40 degrees here. And then the ship sails 10 kilometers in the northwest direction. So after getting to this point, it now sails 10 kilometers in the northwest direction. Also, from this point, you want to draw another cardinal, imaginary cardinal point in your mind or on a rough paper. You have it here, another 4 cardinal point. This is going to be north, this is going to be south, this is going to be east, and this is going to be west to the left here. 10 kilometers in the northwest direction. You will find out that this northwest direction, we are not giving any angle. What does that suggest to us? It simply means that the angle of the sailing of the ship 10 kilometers in northwest will be 45 degrees with the horizontal. So that's why if it's northwest, this is our north. Right vertically upward, our west is horizontally to the left, so the direction of movement of the ship would be in the middle of the north, and west. So that goes from here right up to this direction, and that is going to be 45 degrees because we have just northwest here and the angle, no angle is given. Now this is not drawn to scale. If you are drawing to scale, you know of course that B will be longer than A because this vector, this movement will be longer than this movement. The first movement is 6 kilometers, which is this long. So the next movement should be 10 kilometers. So that should go right up into somewhere here. So because this is not drawn to scale, that's why you have what you have here, right? Let's begin to solve the problem. Now that you understand how to represent this question in an XY plane, this is 45. So the angle we would have from the horizontal to where the vector is at the moment will be 135. By taking 45 degrees from 180 degrees, you have 135 from the horizontal of the movement here in the northwest direction. The next thing we want to do from here now is to try to make some calculations. Each of these vectors would have both vertical and horizontal components. How do we find the vertical and horizontal components? Again, you are going to apply the concept I told you in the previous video. So if you have not seen the previous videos, if you have not watched the previous videos, I think we've had about 3 or 4 videos about vectors and their components now. If you have not checked them out, check them out so you can understand how to find the horizontal components and vertical components of different vectors. We know that our A represented here is 6 and then our B is 10. So the horizontal component will be AX will be equal to A cos the angle the vector makes with the horizontal. So we have A cos 40, which is going to be equal to 6 multiplied by cos 40, and that gives us 4.6 kilometers, by the way. So you should put kilometers here. It's not written here, so you should put 4.6 kilometers here. All right. Also, for the vertical component, you can say that our AY, which represents the vertical component, will be equal to magnitude of A sine 40. How we get this cos and sine, you can easily understand that when you check the previous videos, and that gives us 6 sine 40. That's about 3.87 kilometers. Also for our B, the horizontal component for B, which is BX, will be B cos 135, which is the angle the vector makes with the horizontal component. So we have B cos 135, and that will give us 10 cos 135, which is equal to minus 7.07 kilometers. Now there is a question going through your mind, and that question is, why did we not use 45 degrees here? Now I'm going to explain to you right now. We are using 45 degrees because first the ship is moving in this particular direction. So the ship is moving this way, so from the horizontal positive to this direction. But what we know is that the ship is in the negative x-axis. If we are going to use 45, we will start by writing minus at the beginning here. So if you put minus at the beginning, you have minus the magnitude of b cos 45. If you do that, you would obtain minus 7.07. But because we chose to use 135 degrees, we didn't have to put minus here because this is in the positive direction. At the end of the day, what we did here and what you would obtain if you use minus b cos 45 would be the same thing. Okay, so please understand that. If you have any question about this or any doubt in your mind, put the question in the comment section. I'm going to get back to you and provide more clarity on this. Also for b, the vertical component of b is in the positive y-axis. So this is going to be b sine 135, and that gives us 7.07 kilometers. All right, so now that we have those, we take it a step further by saying, what is then the resultant vector for the ship? It will be given as rxi plus ryj. Now we have all the x components, we have all the y components. So rx will be the summation of all the x components, and that gives us 4.6 minus 7.7 kilometers, which is minus 2.47. Ry would also give us 10.94, as you can see here. If you put both together, you find out that the resultant vector will then be minus 2.47i plus 10.94j. And then from there, you go ahead and find the magnitude of the resultant vector. How do you find the magnitude? It becomes the square root of the horizontal component, minus 2.7 squared, plus the vertical component, 10.94 squared. If you find the solution to this, you obtain the magnitude of the resultant vector as 11.2 kilometers. Your examiner would also want to see these. Now, we want to find the direction, which is going to be the last thing to do here. The direction is given as tan theta equals the vertical component divided by the horizontal component. And that gives us theta equal to tan inverse of vertical component 10.94 divided by minus 2.47. And that gives us minus 77.3 degrees. So the direction of the resultant vector is going to be minus 77.3 degrees, and then you subtract this minus 77.3 degrees from 180 to get 103 degrees. Now I know there is another question going on in your mind. Why would we have to subtract this minus 77.3 from 180 to get 103? I'm going to try to answer that right away. If you go back to this analysis, you find out that if we had drawn this particular vector right up here, right, you can draw an imaginary line to let us know the final position of the ship with respect to its starting point. You draw that line from the starting point and then you draw it up. But now that we have it here, just draw the line this way, draw it this way, draw it right until you get to this particular point. So this is where the ship stopped and this is where the ship started from, and then this is going to represent the resultant vector r that we just obtained, which is 11.2 kilometers. It's going to be this way. Now if this is r, the angle that we are looking for is going to be somewhere in between it's going to be the angle the ship makes with its horizontal. All right, so this is going to go this way normal. So that angle is what we obtain as minus 77.3 degrees. If we had drawn this to scale, you will find out that this angle would actually be in the negative x-axis. Here it is not in the negative y because we didn't draw this diagram to scale. So in the negative x-axis, we have 77.3 degrees. Now, if you measure that negative x-axis will simply mean the angle the resultant vector makes with the negative x-axis. So this minus, if the line were to be drawn to scale, it will be somewhere here. This will be 77.3 degrees. So it is minus because it is in the negative. To get the angle from the origin to this place, to the vector, from the origin to the vector, will therefore be, the angle on a straight line is always 180 degrees. So if you take 77 degrees from 180, you obtain 103. It simply means if the vector, final resultant vector is here, the angle from the initial starting point up onto that vector would be 103, and this will be 77, of course, minus 77 because it is on the negative horizontal axis. If you do have any question about this, get in touch with me in the comment section. I will try to reply you and try to provide more clarity. This is very important for you. Hello guys, this is the last question I promised to discuss with us on our conversation regarding vectors. So example 9, this practically falls under uniform circular motion. So given the Earth's radius as 6.37 times 10 raised to the power 6 meters, what is the circumference in kilometers? What is the surface area of the Earth, and what is okay? So the first question, the circumference will be given as 2 pi r, which will now be equal to 2 multiplied by pi. Our pi is usually given as, you know that our pi is 22 over 7. So 2 times pi is going to be 44 over 7. You do know that this is our r. 44 over 7 multiplied by 6.37 will give you 4.204 times 10 raised to power 7 at the end of the day. This is very important. If you consider the 10 raised to power 6 here, you have these at the end of the day. So converting meters to kilometers will just be dividing by 1000. So you divide this by 1000, and then you have your 4.0024 times 10 raised to power 4 kilometers as the circumference of the Earth. Second question says, what is the surface area? What you want to consider is the area of a sphere is 4 pi r squared. So we have 4 times 22 over 7 times this radius squared. If you multiply all of those together using your calculator or any other means, you obtain 5.1 times 10 raised squared meters. Now, how do you convert these to kilometers? This is meters squared, so you divide by 10 raised to power 3 squared. That is, instead of dividing by 1000 in this case, you divide by 1 million. That's why we have 1 million squared, 1 million meters squared here. So if you take care of that, you have 5.1 times 10 raised to power 8 squared kilometers. The last one says, what is the volume in cubic kilometers? For the volume of a sphere, we have it to be 4 over 3 pi r cubed. If you supply pi as 22 over 7 multiplied by 4 over 3 multiplied by the radius given to us raised to power 3, you obtain something like 1.08269 times 10 raised to power 21 cubic meter. What do you do here? To convert this cubic meter to cubic kilometer, you divide this entire expression by 10 raised to power 3 raised to power 3, which is 10 raised to power 9, 1 billion. When you do that and you try to deal with it arithmetically, you obtain 1.08269 times 10 raised to power 12 cubic kilometers. That's all for this question. See you in the next video. But before then, if you have watched this video to this level, it simply means that there are about 8 more examples before example 9, and then there is a summary or a topic that I discussed on vectors and their components. So there are a couple of videos, about 3, 4, or 5 videos that you need to watch to balance your training, your understanding on vectors. Please do that, and if you do have any question regarding this particular question or any other topic that we discuss, make sure that you get in touch with me in the comment section. I always check my comments. I always make sure that I'm in touch with the people who are in my community via the comment section. So I check it and I try to answer all the questions. See you. Recommend this video to any of your colleagues who you think might benefit from this.